Welcome to the Code Mental channel. My name is Armindo and my channel is all about software development and Python programming. In today's episode, I'm going to continue my setup of my development environment for the Raspberry Pi and TensorFlow and OpenCV. So last time I did a stream, I was trying to set up a Docker container with TensorFlow and 2.3, the latest version. So it took me a while to get that up and running. So today, the actual goal will be to try and set up OpenCV as well in the same Docker container. And I will also do some practicalities that I need to do if I want to be efficient in developing. For instance, I don't necessarily want to actually have to develop on the Raspberry Pi, which I have here, because it's slower than my own computer. So I'll be using an IDE in my own computer, and then I'll be synchronizing the code to the actual Raspberry Pi automatically. So maybe I should start with that first, because that's going to make my life a lot easier. If you have any questions, I'll be monitoring the chat section in case you do have any questions. And feel free to ask questions. So what else? I'm trying to do a wildlife camera with the Raspberry Pi. So this is part of a series of episodes which I'm recording for YouTube, where I actually do live coding. I do everything without any preparation, because I think that's the most valuable for you if you're trying to learn Python, TensorFlow, AI. You know, it's important that you see how it's actually, whatever difficulties I need to overcome, it's probably the case that you're going to have the same issues. So I think this is going to be helpful for you and for me. So let's get started. Right. So the first thing I'm going to do is I'm going to continue drinking a bit of my coffee. You never can start coding without coffee. At least not for me. Right. So I had created a GitHub, which I can't see now. Wait, hang on. Where is it? Yeah, so it's here. You can see my GitHub. I'll put the link for you in the chat section in case you don't have access to it. Right, so. Okay. Just need to check what I'm up to. Okay, so I have already in a Raspberry Pi a folder. I'm going to make this a bit bigger. Zoom in. Control-Shift++. Okay. You can see all right, yeah? So if I go into my folder, okay, so this is where my GitHub repository is currently sitting. Okay, this is in the latest version. I'm going to do also the same thing locally. So I'm going to open a terminal. So I'm going to share. This is the terminal in my actual computer. All right. So let's do this. So I'm going to make, 1 second, I need to see if I have anything confidential here first. Nope. Nothing confidential. It's good. Right. Okay, so I'm going to actually clone the project on GitHub as well. Git clone. Okay. So the stuff I'm doing now is going to be practical for many projects you might have. Because the point is, I need to execute code in a Raspberry Pi, and I want to do it in an efficient way, so without having to copy files over and over again. So my option, first option would be to try and make a change in my computer and then commit it to Git and then do a pull from the Raspberry Pi. It works that way, but it's still not the ideal because I have to keep committing stuff. So I'm not going to do that. So instead, I'm going to be doing an rsync. But before I do an rsync, I have to show you this. So I have a Raspberry Pi in a, yeah, currently asked me for password, which is no good. I don't even remember my password now. Hang on. So the first thing I'm going to do to make my life easier, whoops. I'm pretty sure I remember my password, but hang on. I just logged in. Okay, I don't think my user has even SSH access. Sometimes you can actually give access to certain users from SSH. I can log in from here, so it means I don't have SSH access. Host.allow. What would I be looking for? SSH deconfig? Allow groups. So Pi belongs to the SSH group. So I need to add my username as well to the SSH group so I can do this. It's quite interesting how you end up trying to, I mean, I'm trying to do something, but then I ended up doing something else. And then instead of doing that something else, I'm doing something else. It's the way it works. So I need to figure out how to add a group to user. I don't normally remember those commands by heart, so I'm going to do a bit of a Google search just to remind myself. Yeah, so I do a lot of that. Mainly because even if I memorize a command for Raspberry Pi, then if I try to on another type of server, I would forget as well. It would be different a little bit. How to add groups to user in Raspbian. Okay. Add a new group. Okay, so let's see. So if I want to add new user to the group dial out, I just have to type this. Simple enough. So sudo add user Armindo to, which is my real name, by the way, if you haven't figured out, to dial out to SSH. Okay, so by doing this, I should be able to SSH as myself. It's going to make my life easier. Okay, so now it should accept my password. So I've gone one step further. It's great, but it's still not enough. So the next thing I want to do is to prevent, I'm going to remove the password itself. In a sense, I'm going to use an SSH key. So let me see if I already have, okay, I already have a known host. So I need to add a file called authorized keys, which I don't have. So I'm going to create one. And I'm going to, what I'm going to do, and I'm actually going to do this in, I'm going to have to hide the screen, but just to give you an idea. Let me just go into another terminal. So I have my own SSH keys. Oh, I don't. That's even better. That means I can create one. So SSH key, it's a new laptop. I'm going to generate a new SSH key, yeah? And I'm not going to show you too much of this. Okay, so I'm just putting a passphrase. And then I'm putting the same passphrase again. And then that's it. I got an SSH key. So this will be useful. SSH. Okay, so you see I have two files here. One is IDRSA, is my private key, which I shouldn't share with anyone. And this is my public key, which I can share. Even if someone finds out this key, it doesn't give them access to my, it doesn't allow anyone to pretend they are me. But if they were able, if someone is able to get hold of the IDRSA file, then they will be able to pretend they are me and potentially compromise certain, you know, things that I'm, yeah, compromise my security basically. So they might steal your, I don't know, access to GitHub or do a lot of damage with it. So don't give it to anyone. Keep it safe. So let me just check one thing. I need to put, so if we, okay, right. So I have created an SSH key, and what I'm going to do, actually, I'm going to take the public key. I'm going to take the contents of the public key, which I'm not going to show here how it looks like, even though it might not be a big deal if you see it. I still don't want to share it. So I'm going to get the contents and then go into the Raspberry Pi. So let me just check. So if I go to the Raspberry Pi itself, so I'm just going to paste that into the authorized keys file. Okay, and then after I do that, now I can show you what I'm doing. I need to make sure that the file permissions for the SSH authorized keys are correct. So right now it's RWRR. So in order for this to work properly, I need to make sure this is only readable and writable by myself, nobody else. So I need to change the permissions. So there's two ways of doing that. Okay. So I'm going to do it the intuitive way first. So for, why is it not? Okay, so I'm going to do the, I don't normally do this, but So U plus is RW, means like readable and writable for the user. Oh, this is where I don't even know if I can do this. For the group is like minus, I don't know, to be honest. Well, I only know the numeric in this case. So it's 600. So, which means I thought I was going to help you, but what I'm doing here is setting the permissions to read, writable. Okay, authorized keys. So you see, I've changed it to RW. So what does 600 mean? Means 6 means, okay, each letter here has a value, right? For R, it's 4. For W is 2. And for X, which is not showing here, X means stands for executable, W for writable, and R for readable. So if X was here, it would be a 1. So if I wanted to give read, write, and execute permissions, I would put a 7 for this. Okay? So for example, if I did this here, it would be 700. And you'll see RWX, okay? So R is always a 4, W is always a 2, and X is always a 1. And then you sum them all together, taking into account what kind of permissions you want to give. If I only wanted to give read the only permissions to myself, I would put 4. So it means I don't have permissions to write or to execute, which is annoying, to be honest. It's not secure anyway. So I might as well give it RW. And then what is the other digits for? The other digits is, if I want, so the leftmost digit is for the user. The middle one is for the group permissions. And then the one on the rightmost digit is for like everyone else. So you can set the file permissions for yourself, for your group, and for everyone else. Okay? But in this case, I only want to give access to myself for this file. Because if you allow someone to change this file, right? Let's say someone else, another user is able to change this file. They could be able to, by doing that, they would be able to change to your user and do whatever they want in your directory. Okay, anyway, maybe it's a bit too much explanation. You probably know this already, but you know, if you don't know, this is what it is. Okay, so now I should be able to log into the Raspberry Pi without having to put a password. Got it? So it's working now. So no password anymore. That saves me from typing, and it saves me from well, it's going to help me with the rsync, which I'm going to do next. So for the rsync, it's basically, the idea is I'm going to develop everything in my own computer, and every time I change a file, it will copy straight to the Raspberry Pi. And in this way, I can just run things directly on a Raspberry Pi, and that's going to be a lot easier. Okay, so the rsync, I'm going to try and find some previous code I had, because I've done this before. I'm not going to, the rsync is a bit of a long command, so I don't want to do it again. I figure out once it's enough. And to be honest, I still feel I don't understand that command at all, but let's do it anyway. So I'm going to, so as I used to have another project which is similar to this but different. So I'm going to change the directories. So projects. Okay, I'm going to have to find out the directory. Okay, so Raspberry Pi, Docker TensorFlow. Just, it's a one long string, so I might as well copy it. Oops, I'm missing the /. By the way, welcome to the stream. If you have any questions, let me know. So I'm currently setting up my development environment. Right, so I don't think this is 100% right. Okay, so I don't need to port. The port itself is not needed here. I'm excluding certain files here to make sure that I don't copy them by mistake. For now, I'm going to ignore these exclusions because they are not really important. So, okay. So I'm actually reusing a command I've set up before. Pi at Raspberry Pi home Armindo. Okay, let's see what path is. So this is the path. Something useful. I think the Raspberry Pi supports this. Oh, read link. If I use read link -f, it gives me a full path to a directory, so I can just copy and paste it. In this case, I need to give it the full path. Right. So this is it. So what I'm going to try and do, I'm going to try and run this and see if it works. I don't even know if I have Rsync already installed in my computer. I do. Okay, so something is running, right? And the only way to find out if it's actually working is just to try and copy. I'm going to try and create a file here and see if it shows up in a Raspberry Pi. If it shows up in a Raspberry Pi, then I'm good to go. I have a feeling it's not going to be that easy. Okay, so what's going on? So it's not doing anything. Okay, this is excluding hidden files. Oh, sorry, I'm testing in the wrong place. I'm supposed to create files here to see them in a Raspberry Pi, not the other way around. Okay. So, but still not working. Oops. Let's see. Oh, it failed because I don't have Fswatch. That means I need to search for that. I need to install it. So Fswatch basically checks for changes in files, and the idea is I check for changes in files, and if something changes, then I'm able to make it will synchronize. So how do I install this? I don't have brew. Mac ports or brew. Do I have either of them? I don't think so. So how do I install this? So to install this, I need to install something else. Classic. So much fun. Okay, So I'm going to see if I can install brew. Okay. I hope I don't have to install gigabytes of stuff just to install brew. I have a bad feeling about this, but you know what? Let's have a look. Maybe this is just a bad feeling. I just hope this isn't. Okay, so it's giving me another command. I'm going to run another command. Oh, what did I do wrong? Okay, so press return to continue or any other key to abort. Okay. So it's downloading Xcode command line tools, and then because of that, it might actually end up having to install another million things. It's no fun. So I'm just waiting. It's taking a bit of time. Well, it's not too bad. So I'm just installing something. Bear with me. If It's taking a bit of time. Right, so I'm currently just setting up my development environment, and it seems like it's finished just now. I was installing Brew so I could install Fswatch, which is a utility to allow me to monitor for file changes, which is also something I was trying to do because I was trying to set up an Rsync between my laptop and the Raspberry Pi so I can make changes in my laptop and see them happen straight away in the Raspberry Pi. So it seems like I've managed to install Brew. Let's see if I can now install Fswatch. Should I do sudo? I don't know. I'll find out. Okay, so Fswatch should be installed now. No? Okay, so I have Fswatch. So I can try and run my overly complicated rsync, which I'll put, I'll take note of this, because later on I'll put that into some instructions I'll create for you, so you can follow what I've done. Yeah, so the baby's running. So, I don't know if it's a good analogy or not, but let's see. So I'm going to make another change here, touch test 3, and I should see it in the Raspberry Pi. It didn't work. No, it's working. Let's see. Could be because of some issue. Okay, it did see the change. So it's sent. It didn't. What happened there? It doesn't seem to be working. Okay, test 3, test 4. Okay, doesn't seem to be working. Okay, so what's going on? Oh, I see. It created another directory inside. This is not at all what I wanted. So let me just delete this. Okay, I'll delete it once I stop this. I was so close. I just have to figure out which. Okay, so here. But I don't know. I need to look at the original. Rsync. Okay, you know what? I don't mind, because if it does work like that, I'm just going to remove this. Yeah? So now, every time I change something, test 5. Still. No, okay, I know what it is. I'm going to do it again. Okay, it's working now. Don't ask me why, but the reason why it seems to be the case I need to run it twice is because it saves something into a variable, my script. But when it actually runs, so I create an alias called run_rsync. Okay, actually I'm trying to do things in 2 goes. I should just do this. Oh, but okay, let's see. No, this is the hurts that. So this is actually an alias. So I just have to call this alias and it will do the complicated rsync I did just now. Okay, so and I can make changes directly, which is fantastic. So this is my project. It wants to give me, ask for all kinds of permissions. Oh no. So I'm trying to close something else which I don't need. Can't get rid of this. So something is blocking my blocking my ID, so I need to kill it. I'm trying to kill this at all costs. It doesn't seem to be working for me. What? Keeps opening new processes. Oh, I hate when basically I'm trying to do something else and I have to now figure out what's going on with PyCharm. Okay, let me try this one. Aha, got it. Now it's dead. So let's try. I'm going to start the ID again to see if I'm luckier this time. Okay. Open. Why does it not show me? Okay, open. Not this one. Oh, another one. Projects. Raspberry Pi. Okay. Fingers crossed. Yeah. Okay, so I can delete these files. And this should also delete it from the Raspberry Pi. Hopefully. Let's try it. Delete. Let's see. No, it doesn't seem like deletions are not implemented. Okay. Maybe that's better, right? Because if I delete something accidentally, I'm going to just double check that if I create something in a Raspberry Pi, whether it's going to be created locally, and I don't think so. Okay, so only one-way synchronization, okay? So it's okay, because I think everything I'll do is here. Okay, right, so last time I set up this Dockerfile, and this has TensorFlow. I also created a Docker image and I pushed it into the Docker class, so I don't have to go through this process again because it took quite a while. So I'm actually going to rename this. So because I'm not going to start from scratch again, right? So this is TensorFlow. Yeah. Okay, maybe this is one of those things that it's probably going to mess up Raspberry Pi as well. Okay. Because it doesn't do renames as well. Okay, but in this way, so if I go, so what I'm going to do, I'm going to the Docker Hub, where I've created my image. This is the image I created last week. Someone already downloaded it. This is the interesting thing. I create quite a few images, and people just use it, which is great. So I'm actually helping out, you know, by actually pushing this to the Docker Hub. Anyone who wants to use the same image again, they can use it. Okay, so I'm going to use this one with TensorFlow already installed. So I'm going to create another Dockerfile. And it's going to have from something like this, latest, the type. Yeah, so now I should be able to, oh, why is it read only? It shouldn't be read only. Okay, it's not read only. Okay, so Dockerfile, and I'm going to try it out. First of all, I'm just going to run as it is in the Raspberry Pi. I still have the images from last week. I'm going to stop it. Yeah. Okay, so now it's stopped, and I'm going to start it again. And it should, I think I didn't do one thing which is quite important. I need to build it so it picks up the changes I've made. Failed to build manifest for, okay, maybe I don't have that tag, so I'm just going to remove this. Okay, you should have picked up my change. Okay, it takes a few seconds. If I'm too quick, it will. What? Manifest unknown. Let's see if I miss something. Oh, the tag itself. I need to use this tag. So it gives me the exact version. Okay, so it's already here anyway, so that's why I didn't have to download it. Okay, so if I want to start it again, So it's already started. Hang on. I'm going to stop it and start it again. So, okay. Okay, so I've done that. So it's up and running. I didn't stop QuickTime. Okay, fine. So, okay. So next is OpenCV. So let's figure out Raspberry Pi, OpenCV. And I really want to find something that doesn't require me to compile everything. I'm scanning the page to see if it goes straight to the point or... Besides OpenCV, I'll probably also want a bespoke version of FFmpeg, which will allow me to do a lot of useful things that I can't necessarily do. Well, OpenCV comes with FFmpeg normally, unless you disable it. So this is the dreaded part of compiling. It can take a while. So if I can find something already ready to go, it's much easier. But I might have to do that. No, I've done it. I've done it before. Okay. I like this website, by the way, pyimagesearch.com. I've learned a lot of good stuff about, you know, machine vision, OpenCV, and so on in this website. So I highly recommend you to have a look. Okay. So, but I want something done already. Docker. So there's someone who's done this before. I think even myself, I've done it before. And I put that. I might have to go back to my previous code. I even have ffmpeg. In fact, there's a website used to have a version of ffmpeg which would be compiled already for you. And I might want to do that as well now. No, this is not the version I want. OpenCV. Okay. Okay, I'm going to let's see. So I need to update the versions of files that I have, and so I don't know if OpenCV now has a later version, so I'm going to try and use the latest possible. Of course, there's always the possibility that if I'm going to use OpenCV 4 instead of 3, all these arguments are probably going to break. But let me go into GitHub. So OpenCV is actually an open source project started by Intel, and it has some amazing stuff for computer vision. So, you know, if you want to work with computer vision, or it's basically a compulsory thing you need to use. So this is the GitHub project, and the latest version is like OpenCV 4.5.0. I'm always worried to go to the latest version because I don't even know if that's going to work on the Raspberry Pi. I'm a little bit wary, to say the least. They don't specify. Okay, so let's see. It's a risk, right? Source code. I can download the source code and compile everything. Let's see. Yeah, you know what? I'm going to comment out the previous one because I know this one works. If I end up facing lots of issues, I can always go back to the version I know works. Because I don't fancy necessarily having to deal with things that, you know, don't necessarily work in the Raspberry Pi. Okay, so let's see if I'm lucky. Chances are I'm not going to be lucky, and this is all going to break very quickly. And just okay, this is Linux. Okay, I'm looking at the wrong. Am I looking at the right? x86 is the wrong architecture. Sorry, I might have copied the wrong bit of code. I'm a bit worried about this because, first of all, The architecture here is specified as AMD 64, x86 64, and I know the Raspberry Pi is an ARM architecture. But I've used this before on the Raspberry Pi, so I don't know why I had it like this. So I'm just going to see what happens, really. I think I might also have another error because I haven't installed FFmpeg yet. But let's try it. Why not? See how much it blows up. It will blow up. So first of all, just check that my synchronization is working between the laptop and Raspberry Pi. So I see that it's actually working. Okay. So if it's working, then it means I can just do a docker compose build and see what happens. Okay, there's an error in line 12. So line 12. What? I guess it's just I didn't copy everything in back. Oh man, this is huge. Okay, seems like I fixed the error. So first problem is why the file didn't work? Oh, hang on, I forgot to wget. Right. Okay, so now it's downloading. Four 4.5.0 OpenCV, that's the latest, pretty much. I'm not necessarily very comfortable trying the latest version of OpenCV because you never know what bugs they might have. So if okay, so there's no unzip. So I need to install that. Run apt-get update. Let's see if that works. I think I should have done a -y. -y means it will not ask me if I want to install or not. It will automatically confirm. It seems like it's smart enough sometimes to continue without asking for your confirmation. Okay, so it's done again, OpenCV, and now you should have a unzip. Okay. Oh. So it seems like it didn't ask me confirmation for unzip, but it asked me for installing cmake. Strange. So I'm going to do -y. The other issue I might have is to access the API from Raspbian, because my container is not necessarily like, I don't think it has the library itself. Just try and figure out that. Okay, so there is a good tip here. Instead of trying to mount all the dependencies into the Docker container for the Pi camera, I can just mount this folder when I build the Docker container, or when I run the Docker container. So I'll do that. So I'm going to keep this in mind. Mm. Takes a bit of time. I mean, in the meantime, I'm just going to read it a little bit more. So I can install the libraries. Nice. Okay, it's finished with a bang. Means like I wasn't lucky with this make. Okay, so is it because minus enable shared? I think I don't have a. I'm missing a space in this massive command line. So I'm like, I don't even know where to start. Enable shared. Oops. Because build quite horrible stuff, to be honest. cmake error. Look at this. Okay, something to do with this. I need to consult something. I didn't have to do this before. Space. Doesn't like it. I think this is part of the same one. Just wraps around. I'm not going to take any risks. It's not working. It's a bit strange. So I need to do not really helping, is it? You know what? I'm going to comment this out. And I'm going to take a look inside the container. What? Seems like it's restarting. So why? Okay, I know where it is. So I just need to make sure it doesn't stop. Because the Docker container is supposed to always run something. If there's nothing to run, or that whatever you try to run ends straight away, then it will exit straight away. So that's what's happening just now. Okay, now it's not exiting, so that's a good sign. So I can go inside the container and take a look inside and see what's going on. Okay, so I can see that this directory is empty. So why does it really? So what I don't understand. Okay, I'm going to downgrade to the version I know of that OpenCV used to work. And then if once I get that to work, then I can exclude. There is something else. Well, at least I will know if I'm facing an error because of the version is different, the way it compiles is different. It's going to tell me something first. Okay, so let's try it. See if it makes any difference. Well, it seems to be doing potentially more, I don't know. So OpenCV itself, don't know if it comes with FFmpeg or not. It has an option to include FFmpeg libraries. So internally, it will be able to use FFmpeg, but I don't think it actually uses executable. So you don't need to install FFmpeg before you install OpenCV. Hoping to get to the exciting part today. But for now, it's all about installing packages, setting things up. It's boring, but it's necessary. Okay, so it seems like it compiled this time. So I have OpenCV installed. I don't necessarily like to use the old version of OpenCV. It'll be nice to use OpenCV 4, right? So let's see if I can get that to work. At least I have a baseline that I know works. OpenCV. So we're installing everything from source. Oh. So here it's using version 4.0.0. So which version am I using? OpenCV version. There's contrib as well. I know it does something important. I think it gives you additional libraries, contrib, which we are probably going to use as well. And then cmake. Just need to compare against his. Yes. I already have contrib here. Oh, hang on. I thought I installed something. I didn't install anything. Okay, so the actual issue is not to do with the version of OpenCV, it's just some copy and paste error I have. I copied this from another file I had, so it must work. Let's do the brave thing, which is to start again. I still have more things to copy later on, but let's do this. It's a lot of fun. Installing packages. And, thankfully, I've done this once before. Otherwise, I'll be really learning from scratch. And I'm missing, for some reason, no. The source directory does not exist. I'm going to just search for this error. I think it might be the case that someone already had this error. The last argument to cmake needs to be a directory containing a cmake list. I think I know what it's been. Just guessing. The work directory should work, but I'm just trying to. I'm a bit desperate with. But I don't know why this is. It should be the last argument, right? Mm-hmm. No cmake. Hmm. Okay, so this could be because I'm missing some dependency. Oh, damn it. Let's just close my browser. I didn't intend to do that. This is a Raspberry Pi. Okay, so there's no cmake compiler. So that means I'm missing some kind of dependency that comes before. Okay. Build essential. Okay, I'm missing a package. Build essentials. And I'm going to try and change this to 4.5.0. 4.5.0. Can get really complicated dependencies, installing packages, especially when you're dealing with OpenCV and TensorFlow and FFmpeg. It's a bit of a nightmare. But once you've done that, that's half, well, not half, but it's a lot of the work that we need to do. Afterwards, it's going to be fun. A lot of fun. if you are rewatching the live stream, you can always skip forward up to the point where the action is all happening. Because right now I'm just waiting for this OpenCV to set up. I might get an error now. It's worth watching. Fail again, who knows? But I've installed build essentials, which allows me, should have the compiler there. So now when it tries to set up OpenCV, it should hopefully compile. But, you know, I'm not very confident today. It would be nice to have, if you have any questions, let me know. I'm kind of free right now. Okay, it's doing something. More packages. Some more interesting stuff's happening. The red stuff is just a little bit of, it's a warning. Scared me for a bit. I think it's compiling something now. So in the meantime, while it's doing that, I'm just going to check something that maybe I should have checked earlier. Where's mine? I want to open again that website, file image search, because it mentioned something important that we need to enable. This one, OpenCV enable non-free. So, okay, let's see if I enable that. Enable non. Okay, maybe it's in lowercase. Non-free. So let's see if it's different type of arguments. It's -d. The ones I'm using are okay. I probably want to add this argument there. I'm going to do that. so I get access to the good stuff, you know, like stuff that has patents. But because I'm not doing anything commercial, I should be okay anyway. But there's one secret about this. If you distribute your software without OpenCV or FFmpeg, you should be okay. But then you need to tell people, okay, you need to install FFmpeg and OpenCV separately if you want my stuff to work. The reason is, and this is something about the licensing for FFmpeg and will affect OpenCV as well. If you decide to include FFmpeg in your solution, you are required to publish all the source code online. In my case, it doesn't matter because I'm going to publish anyway, but the license is quite strict in that regard. So that's why normally you will have to compile things. In this case, you have to compile OpenCV to enable FFmpeg separately. But you know, I like these options that you get because sometimes you are just prototyping a product. You don't want to worry too much about patents at that point. You just want to make sure that your solution works. And then once you have a solution working, you probably want to figure out what patents you need to acquire or what licenses you need to get. You know, there should be a minor problem later on down the line when you have something really good working. I have no idea what this algorithm is. It is enable neon. Let's find out what it is. OpenCV. Okay, I'm going to just add the things that I'm missing. Things should be important. Going to add. I need to make sure. So I'm in this wonderful world of trying to make something work. I'm getting there. So I need to follow this contrib. Same version for contrib. And then I need to move contrib just going through the actual steps here to see if I need to change anything I've done. I almost feel like I should be copying from this tutorial rather than trying to adapt some code I've used before, because it wasn't really complete. Okay. So I've added this enable non-free. I'm going to add some extra lines because otherwise it's very hard to read this. Just remember, all this pain is for something much greater than this. So this suffering is not in vain. When I say suffering, I mean having to deal with mile-long compile statements like this, which I have no idea. I'm not going to change at all. Okay, so I just have to make sure that this line is also there. I'm going to also make my life easy by trying to subdivide these in multiple lines. Okay. Oh, why do I have two? One is enough. Right. It has a lot of parameters here, as you can see, and it's no fun. Not really fun to do. So, but once you compile this, It's telling you to increase the swap space, but I think I have not faced any issues. And you can also use make -j4, which means it uses the 4 processors in your Raspberry Pi. The 4 cores. Okay, let's give it a go. It's going to blow up. Okay, line 24. Okay, missing /. Right. Okay, more fun. Actually, I've made a mistake. I'm going to cancel this. I didn't check the directory. It's correct. Oh, it would be working anyway. It's running as root. Okay, I'll do it again. So, oh no. OpenCV no such file or directory. Oh, why did I download version 4.0.0? I should get some kind of variable in here, so I don't necessarily have to always change different parameters. I'm going to do that. I don't remember how to do it, but Docker file variables. I'm pretty sure Dockerfile accepts a variable. I just want to be 100% sure. I have an idea how it works, but I just want to be sure. Okay, so env equal to bar, and then I can just use that in the statements themselves. Okay, that's good. Let's try that. So env OpenCV version equal to 4.5.0. So instead of just always specifying the version, should be okay like this. I could use a curly brackets, but I don't think I need to use it here. Let's see. So now, if I want to change the version, I only need to do it in one line. This is I think one guaranteed success I should have is to be able to install OpenCV. That gives me a lot already. Then I need to try OpenCV by just running a random something. The simplest OpenCV program I can find. I'll run it and see if it works. I'm using a remote desktop to access the Raspberry Pi, so that could also give me some issues later on. So I need to basically whatever happens, I need to resolve that. So it's training for long, 2 hours. So I have TensorFlow, I'll have OpenCV, I'll probably also have to install FFmpeg at some point. Even though OpenCV includes its own, it includes FFmpeg. But I want to have another standalone open FFmpeg. So FFmpeg is basically the Swiss knife of dealing with video. If you want to do anything complicated with video, try it first with the FFmpeg. And FFmpeg supports pretty much all the streaming formats, the popular ones at least. And you can basically experiment with it. It's good for prototyping. So it's compiling. It's good. Complaining about Python libs. It's doing something. Downloading more things. No way. It's almost done. It's almost impossible to believe it. Let me see what's next before I get too happy. So after the build, then I need to do a make install. Oh, there's a make. Oh no. Don't tell me I'm actually still have to do another make. Okay, so I've done the cmake, and this is where I was kind of confused. Cmake is not enough. Non-free algorithms should say yes. Let's see. Yeah, it says yes. Documentation, no. Okay. If you think this is unavailable, it's complaining about Python. This worries me a bit. Okay. Let's see if there's any more things. I might have to do this. Let me check. I already have the... No, I don't. I have a very small swap size. Okay, let me change that. Okay. Okay, so wait, hang on. Just put here 2038. I have more. 4 gigabytes is here. But this is just swap size. I don't know if it applies to the Raspberry Pi, but just in case. I mean, what I said, I don't think it applies to the Raspberry Pi 4 because the Raspberry Pi 4 I have already has 4 gigabytes of memory. These instructions are designed for Raspberry Pi prior to version 4, which had a maximum of 1 gigabyte of memory. But, you know, it can take a long time to run this, so I don't want to take any chances. And there's no guarantee that Docker will even use the swap space, to be honest. Okay, so let's see. So if I do build again, it should just start from the last step that I added just now. And I might have to basically do something else while this is running, because this can take a long time. Let me see if there's anyone in the chat. No. Okay. 4%. It's not too bad. Okay. Let's start. If there's anyone joining me on the stream, I can see someone. I want to say hi. Hi, how are you? And you can ask questions. It's a good time to ask questions. If not, then I'm just going to continue. So 33%, no point for me to be waiting here forever. I'm going to go to kaggle.com. This is going to be useful later on anyway. So I was taking a course on introduction to neural networks. Oh. So let's go. Excuse me. So my last module I completed was deep neural networks. That was not too difficult. So now I have to do, so I'm going to do module 3, which is Stochastic Gradient Descent. Right, so let me do that. Okay, so scroll down a bit. Wow, I'm not sure if I'm going to finish this today. It looks like a lot of material. Okay, let's read it. I just want to make sure I don't miss anything. Like, I want to see if it's complete or not. Okay. Stochastic Gradient Descent. In the first 2 lessons, we learned how to fully connect, how to build. In the first 2 lessons, we learned how to build fully connected networks out of stacks of dense layers. when first created, all of the network's weights are set randomly, and the network doesn't know anything yet. In this lesson, we are going to see how to train a neural network. We are going to see how neural networks learn. As with all machine tasks, as with all machine learning tasks, we begin with a set of training data, and each example in the training data consists of some features, the inputs, together with an expected target, the output. Training the network means adjusting its weights in such a way that it can transform the features into the target. In the 80 serials dataset, for instance, we want a network that can take each cereal's sugar, fiber, and protein content and produce a prediction for that cereal's calories. If we can successfully train a network to do that, its weights must represent in some way the relationship between two features, between those features and that target as expressed in the training data. In addition to the training data, we need two more things: a loss function that measures how good the network's predictions are, and an optimizer that can tell the network how to change its weights. One sec. Starting to get a bit dark. I need more light. Okay. Right. Okay. So I'm just thinking about what I just read. Right, so the training data that we're using to build, to basically ensure that the training data is the inputs and the outputs. So the inputs, and the idea is we give it a set of data to the neural network, and we tell it what we expect to be the result. And then the machine learning algorithm is supposed to basically figure out how to get from the input to the output. So it will try to come up with some kind of function that will give an accurate value for each input based on the data that we give it. So it will try to fit a function. That's my understanding, at least. So that's the training data. And then the weights and the bias, as we've seen in the previous chapter, is what allows us to basically, it's what allows the machine learning algorithm to adjust. It basically keeps trying, it changes the weights, it changes the bias until it gets to a point where it's getting the right results. The loss function is something that we can use to determine how good the predictions are. So because let's say you start from 0, right? Initially the function that you might get might be completely, it's going to be completely wrong, right? So it's going to give you the wrong results. But then the loss function is going to give you a measurement of how far off we are from the actual expected results. And the idea is the better the algorithm gets, the better the function, the more accurate the function gets, the function that we're trying to create. How do I say, the closer the machine learning algorithm gets into a function that actually gives you accurate values, the smaller the loss is going to be. And then there is a way, seems like the optimizer function is something that we need to call to basically change the weights in an efficient way. So rather than being randomly, or there is some kind of art in changing the weights in a way that it improves things rather than makes it worse. Okay. So the loss function, we've seen how to design an architecture for a network, but we haven't seen how to tell a network what problem to solve. This is the job of the loss function. The loss function measures the disparity between the target's true value and the value that the module predicts. Different problems call for different loss functions. We've been looking at regression problems, where the task is to predict some numerical value. Calories in 80 cereals, rating in red wine quality. Other regression tasks might be predicting the price of a house or the fuel efficiency of a car. A common loss function for regression problems is the mean absolute error, or MAE. A common loss function for regression problems is the mean absolute error, or MAE. For each prediction, ypred, MAE measures the disparity from the true target, ytrue, by an absolute difference, ABS, ytrue minus ypred. So this is a very simple loss function. So the bigger the gap between ytrue and ypred. So ytrue is basically the actual, let's say we are trying to, I don't know, ytrue is the actual value that the true result, basically. Ypred is what our machine learning algorithm actually predicts that the result's going to be like. And the idea is, if the gap between the true result and the predicted result is bigger, right? That means our algorithm is getting worse. If it becomes a smaller gap, then closer to zero, then it means that our algorithm is better, right? It's a simple concept. So this is just an example of a loss function. There's other loss functions. And the total MAE loss. So the mean absolute error, right? It's just an average then of so basically we calculate all the differences given by this differential, right? And then we divide it by the number of values that we get. So in this case, this is the true result and this is a predictor. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have basically sum all the differences, right? And then we divide it by 15. That's the mean absolute error. Besides MAE, other loss functions you might see for regression problems are the mean squared error or the Huber loss, both available in Keras. The point is, right, we shouldn't worry too much how these functions work. In a sense, it's good to understand that it's just a loss function, right? The loss function is going to tell you how good your results are And depending, sometimes you can actually replace the loss function depending on what you're trying to do. But the actual idea is always the same. The loss function gives you, the smaller the loss, the better it is. During training, the model will use the loss function as a guide for finding the correct values of its weight. Lower loss is better, as I was just saying. In other words, the loss function tells the network its objective. Okay. The optimizer, stochastic gradient descent. We've described the problem we want a network to solve, but now we need to say how to solve it. This is the job of the optimizer. The optimizer is an algorithm. Oh my goodness. The optimizer is an algorithm that adjusts the weights to minimize the loss. Virtually all the optimization algorithms used in deep learning belong to a family called Stochastic Gradient Descent. They are iterative algorithms that train a network in steps. One step of training goes like this. Sample some training data and run it through the network to make predictions. Measure the loss between the predictions and the true values. And finally, adjust the weights in a direction that makes the loss smaller. So basically, it's an iteration of changing all the weights and then hoping that you get a better prediction. And the way to know if you got a better prediction is by using the loss function. If the loss function tells you it's smaller, then it means you're going the right direction, right? So the optimizer function, the optimization algorithm is a way to basically try to improve the weights over time. So if the optimization function is working well, then the loss function should return lower loss values over time, over each iteration. Okay, so just give me a second. It's getting quite dark. Oops. Yeah, a bit lighter now. Okay. So we just do over and over the iterations until the loss is as small as we like, or until it won't decrease any further. So sometimes the loss doesn't get any better, any lower. And that's when you know that you've done enough iterations. So fitted line. So this is what we're trying to, so these are the results we're trying to fit. You see, it kind of starts with a very big loss. Then it goes down, down, down until it gets to a point where the loss is as small as it can get. And it's starting, I think it does 150 iterations. Okay. So each iteration sample of training data is called a mini batch, or often just batch, while a complete round of the training data is called an epoch. So the point is, right, sometimes you have so much training data that it's not practical to use all the training data in one go. So you basically select a small batch of data from the training data. And then the idea is you go through each iteration basically picks different training data until it's managed to get a complete round of the training data. And once you get a complete round of the training data, you have an epoch. So you can actually specify how many times you want to train over the same data. So in this case, it's the number of epochs. The number of epochs you train is four is how many times the network will see each training example. The animation shows a linear model from lesson 1 being trained on with the SGD, Stochastic. The animation shows the linear model from lesson 1 being trained with SGD, Stochastic Gradient Descent. The pale red dots depict the entire training set, while the solid red dots are the mini batches. Every time SGD sees a new mini batch, it will shift the weights. Oh, I see. So these are the whole training data set is in like light red, right? And the solid red is basically it represents what's being used in each batch. So yeah, as you can see, it's a small subset compared to the total of the training set. So every time there's a new mini batch or a batch, the weights are shifted. W the slope and B the y-intercept toward their correct values on that batch. So we are shifting the weights. Batch after batch, the line eventually converges. Batch after batch, the line eventually converges to its best fit. You can see that the loss gets smaller as the weights get closer to their true values. But this might not always happen, right? So you don't always get the conversion. Okay. My camera is not be happy today, is it? It's overheating. I need to. Okay, I need to finish, I guess, at some point. Right, so okay, so learning rate and batch size. Notice that the line only makes a small shift in the direction of each batch, instead of moving all the way. The size of these shifts is determined by the learning rate. A smaller learning rate means the network needs to see more mini batches before its weights converge to their best values. The learning rate and the size of the mini batches are two parameters that have the largest effect on how the SGD training proceeds. Their interaction is often subtle. And the right choice for these parameters isn't always obvious. We will explore these effects in the exercise. So if you want to make if you want to learn very slowly, right, you decrease the size of the shifts, which means that the weights and are changed with the smaller values. The shifts are smaller. You can make it faster, bigger shifts, but that means you might not converge as quickly, right? You might actually end up missing. So it's a complicated thing. Like when you say your learning rate is higher, it doesn't necessarily mean that it's learning faster, right? It's not the same thing. It just means it's going to do less batches. So if you increase, so it takes longer to train, but if it takes longer to train, it might actually be, it probably is going to be better, right? Because it's actually testing with more different, I don't know necessarily what I'm saying, but I'm just trying to figure out what they are trying to tell us here. The learning rate and the size of the mini batches are two parameters that have the largest effect on how the SGD training proceeds. Their interaction is often subtle, and the right choice for these parameters isn't always obvious. Okay? Fortunately, for most work, it won't be necessary to do an extensive hyperparameter search to get satisfactory results. Adam is an SGD algorithm that has an adaptive learning rate that makes it suitable for most problems without any parameter tuning. It is self-tuning in a sense. Adam is a great general purpose optimizer. Okay, starting to get complicated. Adding the loss and optimizer. After defining a model, you can add a loss function and optimizer with the model's compile method. Model.compile, optimizer equal to Adam, loss equal to MAE. Notice that we are able to specify the loss and optimizer with just a string. You cannot always access this directly through the Keras API. If you want to tune parameters, for instance, but for us, the default will work fine. Adding the loss and optimizer. After defining a model, you can add a loss function and optimizer with the model's compile method. Model.compile, optimizer equal to Adam, loss equal to MAE. Notice that we are able to specify the loss and optimizer with just a string, and you can always access this directly through the Keras API if you wanted to tune parameters, for instance, but for us, the default will work fine. What's in a name? The gradient is a vector that tells us in what direction the weights need to go. More precisely, it tells us how to change the weights to make the loss change fastest. We call our process gradient descent because it uses the gradient to descend the loss curve towards the minimum. Stochastic means determined by chance. Our training is stochastic because the mini batches are random samples from the dataset, and that's why it's called Stochastic Gradient Descent. Okay, so now we're going to go with, that will be an example. Example, red wine quality. Now we know everything we need to start training deep learning models. So let's see it in action. We'll use the red wine quality dataset. This dataset consists of physical. Okay, I'm going to try again. A second. This dataset consists of physiochemical measurements from about 1600 Portuguese red wines. Also included is a quality rating for each wine from blind taste tests. How well can we predict a wine's perceived quality from these measurements? We've put all of the data preparation into this hidden cell. It's not essential to do what follows, so feel free to skip it. One thing you might note for now is that we've rescaled each feature to lie in the interval of 0 and 1. As we'll discuss more in lesson 5, neural networks tend to perform best when their inputs are on a common scale. So okay. So 0 and 1, this. No. How many inputs should this network have? We can discover this by looking at the number of columns in the data matrix. Be sure not to include the target here, only the input features. So we've done something similar before. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11. So that's what it's currently. 11 columns means 11 inputs. We've chosen a 3-layer network with over 1500 neurons. And this network should be capable of learning fairly complex relationships in the data. From okay. So, what time is it now? Okay. So we see here an example of the definition of the neural network, the 3 layers network. Deciding the architecture of your model should be a part of the process. Start simple and use the validation loss as your guide. You'll learn more about model development in exercises. After defining the model, we compile in the optimizer and loss function. So we use optimizer Adam, and the loss function is mean average. What was it called? Mean average error? I forgot. Mean absolute error. Now we are ready to start the training. We've told Keras to feed the optimizer 256 rows of the training data at a time. So the batch size is 256. And to do that 10 times all the way through the data set. So 10 times batch size to, yeah, it goes. So 10 times the data set. So each batch will have 256 rows, and then we do enough batches to go through the training data 10 times. Okay, so it seems like here there is 5 steps for each epoch. And you can see the loss is going down, goes from 0.29, goes down to 0.10. Here tells you how much time it takes for each step. And then it gives you a value of, what's this? I'm not sure what's volume is called. you can see that carries will keep you updated on the loss of the model as the model trains. You can see that carries will keep you updated on the loss of the model as it trains. Often a better way to view the loss is to plot it, and the fit method in fact keeps a record of the loss produced during the training in a history object. We will convert the data to pandas data frame, which makes the plotting easy. History data frame. So this shows like how the loss goes lower over time. Notice how the loss levels. Notice how the level. Notice how the loss levels off as the epochs go by. When the loss curve becomes horizontal like that, it means the model has learned all it can, and there should be no reason to continue for additional epochs. Okay. All right, next step. I think I'm going to have a break now, and I'm going to, I don't know if I should end the live stream, but I'm going to have a break. So see you soon. Bye-bye. So I'm back. I've had to wait a long time to make this compilation work. And I'm really scared now because if I have to do this again, it's going to be another, wow, at least an hour. So I'm going to be very careful with what I do next. So I did this. So that means the next thing I should do is a make install. And the make install should install everything in the right place. What is LD config for? I don't understand, but okay. I'm just going to do that as well. I'm really wanting, I want to save whatever stuff I've done here and put that into a Docker hub so I can avoid myself the pain of compiling all of this again. So I have now TensorFlow and OpenCV, almost OpenCV. So now I should just have to build again, because this is Docker. It will only like modify the latest layer that I add. So in here, I've added 2 extra lines. That means everything that's up to here, it's not going to try and repeat again. If I was unfortunate to have to change anything before make -J4, then it would have to rerun this again. And that's going to be, as we know, it takes a long time to run that. So I hope that never comes to fruition. So it's installing everything, OpenCV in the right directories. And that means I should be finished pretty much. I don't even know if I have time to test anything, but it would be nice, right? So if I was able to do some kind of test. I think the last thing I need to do is to link Python with OpenCV. I cannot stress this step enough. It's critical. Okay, so I know I need to do it. Right, so all done. And now, last step. I think I need to do this last step by actually going inside. I'm going to go inside the container. I'm going to start it, stop the previous one and start a new one. Okay. And now, so Docker. Because I have a Docker container, I don't really need to create an environment, a virtual environment for Python. It's redundant. I'm going inside the container with an open a bash. It's the equivalent of a Docker exec is almost like you can run any command on it. And in this case, I'm opening a bash, a shell basically. So I am inside the container now. And I can have some tests. So let's see. So let's see where our OpenCV has been installed. Python, no, it's not here. User local share, OpenCV. Then it should have Python. No? There's no folder called CV2. Include. Seems like it's a bit over the place. A bit. OpenCV 4, OpenCV 2. Delete. There's like libraries from OpenCV here. So it's telling me to create a link, a symbolic link. I'm not very confident about this. C Python. Just don't like this. So I don't see any. Oh no. Don't think I have the libraries for OpenCV. That's why it showed me like couldn't find it. So if that's the case, I need to repeat this completely again. Okay, so I'm basically stuffed. But you know what? Before I throw down the towel and give up and do all of this again, I'm just going to confirm, because I don't want to make any more changes to what I've already done for the time being, before I'm sure that so instead of just modifying the previous layers, I will do that later, but I'm going to add a new layer and I'm going to call cmake again. But the goal is to try and figure out the Python arguments I need to give it. It looks to me like it didn't like the Python version I have. So I need to look at it. OpenCV Python requirement. Raspberry Pi. Things I do remember clearly that we did do a test. Could not find Python interpreter. What? Minimum required is 3.2. Okay, couldn't find the Python libs. And it requires exact version 5.3.3. Okay. So I need to somehow resolve this problem. Damn it. So I'm stuck on something, need to figure out a way out of it. Some silly libraries missing. Yeah.
How about him? This I have a tail. She go wherever I go. Bye.
It's a family. So let's go. Okay. So I might be able to include the missing libraries by passing in these two parameters. But I need to change, of course, because my paths are probably different. So much fun. So I just have to search for something like that. Easy. Oh. Okay, so don't see it. Do I even? think this one is probably can't find it. I can't find the file, full stop. Well, at least you can find one. Oh no. Okay, so I'm missing the Python interpreter packages. So if I do this, I don't need sudo. Okay, so this is actually for Raspberry Pi the problem. Fantastic. I've kind of spent a lot of time building something that doesn't work. But that's fine. As long as I can solve the problems. So what I would do, if I am able to get the... Oh wait, I need to remove this. If I'm able to get this to work. So if you can find a Python libraries, I will let it run up to the end, but I'm going to finish that live stream. So I'll give an update. Next live stream, I'll show you how I can set up the actual, well, I'll continue with OpenCV setup. And if we are lucky, we'll be able to try OpenCV in a Raspberry Pi and, you know, have some fun. Pain before fun. It's always the case. So, it's actually installed in Python 2.7 libraries and Python 3.5 libraries. Okay, so anyway, I'm quite happy with the progress today. That means like we have Python, we're going to have OpenCV 4 and TensorFlow 2. So the latest of the latest. Okay, so let's have a look. Found Python interpreter, found Python lib, fantastic. But I don't want him to find 2.7, right? But it's a good question. I wanted to use 3.5. Okay, it's using Python 3 for build. How do I force it to use? It's missing a library. This one. What I'm going to do, okay, so I'm going to remove this section so it doesn't install anything for 2.7. I need to install all of this stuff as well. It's raining. I have to remove this. I just already accept the fact I have to compile everything again. I hope this is going to be a useful video for anyone who goes through this pain. Oops. I need to make sure it's with a -y. Do the same. I should actually have less layers. It's okay. So installing all the packages. Right, so I should be getting there now. Need to just monitor to make sure. Okay, it's installing the Python 3 development packages. Oh, it's actually working. Seems like it. Okay. Sorry, it's a bit boring right now, but It is what it is. I'm installing stuff and it takes time. If you have any questions, feel free to ask. I'll be having plenty of time to answer any question. So you might be wondering what I'm up to. So I'm building a wildlife camera using a Raspberry Pi, OpenCV, TensorFlow, and right now actually I'm doing the boring stuff. I'm actually setting up all the software packages we need. So I've done TensorFlow last week. This week I'm doing OpenCV. And OpenCV is actually proving a bit harder. I'm actually trying the latest OpenCV. So I've realized I miss an important library, and so I wasted like what, an hour and a half compiling OpenCV, but it was missing the Python 3 dependencies. So I had to do it all over again. And this time I just want to make sure that before I waste any more time, that it's actually picking up the Python dependencies. I think it is. So I'll be curious if... Okay, let's see. Python is here. Python libs is also here. So I picked it up. Fantastic. So that means I can just let this go, right? Hopefully this is the last time. If it's the last time. Okay, so I think I've done enough for today. So I'm going to let this run overnight, and you know, our next live stream will pick it up where I left off. I'm just going to leave the Raspberry Pi like that. My next live stream should be next Saturday, and we'll finish off OpenCV. See you again soon. Happy coding!